Lesson 74, Scientific Notation, Saxon Algebra 1. Here we go. Scientific notation always starts out feeling like a real pain in the neck. The payoff will come when you encounter scientific notation in your science classes, in chemistry, in physics, in astronomy, biology too, probably. Understood scientific notation before, and you're going to be like, it's not hard, let's just get this done. Remember, scientific notation always takes the form of a number in the ones place, and there may be digits following that, but this is the most important thing, is that the largest digit is in the ones place, and then we multiply it by 10 to a power. This is the format that scientific notation looks like. And so what we're always doing is moving numbers into this format, combining them, and then, excuse me, and then sometimes moving them back out. We have to see what John asks us to do. But in this first example, 74.1, he gives us a number, 0.000316, and he wants us to rewrite this number in scientific notation. So the first thing we need to do is move the decimal place, right? We need the first non-zero digit to be in the ones place. So we're going to have to move this 1, 2, 3, 4 times. So now we know we can write 3.16 times 10 to the 4th. We know 4 is the right number because we jumped it 4 times, but now we have to consider the sign. When we look at the number in scientific notation, the sign, positive or negative up here, tells us whether this number is going to get bigger or smaller when we convert it back to its actual self. This number, this 3.16, we actually want to make much smaller when we convert it back, right? This number is much less than 1. So this is a negative. If we had a positive exponent, that would mean this number would get much bigger when we put it back into its regular shape. And we would end up with, 31,000 something or other. So this minus sign gives us direction about how to convert this number back to its normal self. And this minus sign says make it smaller by 4 jumps. And that's exactly what we would do. Okay, so this is our final answer. All right. Example 74.2. Now we have a variation on the theme. This time we have our same number, but we're multiplying it times 10 to the minus 7. Okay, so it's not just the plain number, it's the number being adjusted. Well, the first thing we do is we write this number in scientific notation. We already know how to do that. 1, 2, 3, 4. It becomes 3.16 times 10. We know it's 4. Is it plus or minus? This number would have to get smaller when we put it back in its original shape, so we know it's minus. Okay? That's the same. We know that's right. Now we have to, I'm rewriting this here. Now we have to combine those two, because we don't have 2 10s when we have scientific notation. So this stays the same, and we want to combine these two. Look, we've got matching bases that we're multiplying, and we have exponents on them that we'd like to combine. Oh, I think we have an exponent rule. Wait, I've got that plastic stuff on the edge of my paper, so it won't let me do that. X to the m times x to the n equals x to the m plus n. Does this sound familiar? Micah, did you write this in the sand in Hawaii? I hope so. So there it is. We know we need to add those exponents. So minus 4 and minus 7 equal minus 11. And that's our final answer, because we have it in the proper format. Oh, those rules for exponents are so stinking handy, aren't they? I think I can squeeze one more onto the page here. 74.3. This time we have our same number, 0.000316 times 10 to the positive 7. Okay, this we know how to do. We've already done it twice. This becomes 3.16 times 10 to the minus 4. And this time we have to combine it with 10 to the 7. So I skimmed over the first step because we've done it twice. But now our second step, we use the same rule for exponents. We just have a different result because this is a positive 7, whereas last time it was a negative 7. So we add negative 4 plus 7 is 3. And there is the answer to the third problem. One more problem, but it has an A, B, and C. Oh, that is so cheating, John. 74.4, but this is the only topic for this lesson. So we're supposed to write each of these numbers in scientific notation. Let's take them one at a time. A, 47,800. All right, where do we want our decimal to be? Remember, look something like this. So our decimal is here, and we want it to be there. So we need to move it 1, 2, 3, 4 times. 4.78 times 10, what did we say? 1, 2, 3, 4. We know it's 4. Is it positive 4 or negative 4? Positive will make this number get bigger when we convert it back. A negative sign will make this number get smaller. We look at our original number. Oh, we want this to get positive 4. And that's our final answer. Okay? B. 47,800 times 10 to the minus 7. Okay, we just did this up here, so we know it's 4.78 times 10 to the 4th. And now we combine 10 to the minus 7. We know our rule for our product rule for exponents. Multiplying matching bases, we can add the exponents, so it becomes 4.78 times 10 to the negative 3. That's the right answer. I haven't been making my smiley faces. Okay. And then the third one, part C, same starting number, 47,800 times 10 to the positive 7. Again, we can take our previous work. We know how to fix this number. It's 4.78 times 10 to the 4th. There it is. And now we combine it with the second power of 10. We use our product rule for exponents and add them. It's positive 11. Yay. We're going to be adding to our knowledge with scientific notation. We're going to be making it harder over the next year. So don't worry if you still feel a little iffy on this. We're definitely going to do more practice. That is the end of lesson 74. Thanks, guys.